Perfect. So, in these videos, what we're going to do today are some tests on an inverter unit, but assuming that the unit is completely installed. That's why we have the indoor unit here and the outdoor unit here, also partially disassembled. Just by removing a few of its protective plates, we find this part of the unit exposed, mainly the board that is here, where we will start to be able to make all the other measurements. So, we are going to control in this part some parameters that we have already been seeing in the training, but we will do it with the board in place to determine several points or possible failures. At this point, I placed 3 small cables and here 2 that are the ones that are in the signal area with the purpose of showing you and making measurements. You can do it directly at the contact points. The problem is that here you will not be able to grab the oscilloscope, and also remember that they come completely varnished. What you have to do without a doubt is reheat or use test joints that are sharp and that stick, and that can make the measurement through the varnish. Very well, then we are going to proceed now to make some measurements on the board to be able to rule out problems, find failures, and you will see that from the board we will be able to reach even to measure the operation of the motor, the reactor, and the fans, all from this point of the board. But of course, it is very important to understand how it works. It is important to know which UVW goes to the motor, important to understand that C and N is the communication measurement, important to understand that L1 and L2 is always the location of a reactor or reactive coil, and you have to understand it to be able to make the correct measurements. Here we have the other optocouplers, all the pieces that we were seeing in the training, we have them here. And from here we can make those measurements even as I will show you now. At this point you will see that we have the sensors. Let's do a little zoom. Here we have the location of the sensors. I don't know if it can be seen well, but here it says TH. Here we have that sensor measurement. Here we have the LGB is the port where the sensor is placed, of which more later is explained its operation, an intelligent module to be able to make diagnoses. If we observe well, here we have the switch, an 8-terminal component, which is the switch, I mean this one. There are 1, 2, 3, 4, and here there are 1, 2 that is not always placed, 3, 4. Here we have the transformer, and if we continue advancing a little towards the secondary side of the power supply, we will find a 3-terminal component. Generally it is a 7805. And we will find some checkpoint of 5 volts, it says 5B. Here we have the negative, and here we have a checkpoint of 15 volts. We have a checkpoint of 15 volts also, so we have the whole board in view. If we go back, we have the switch as I mentioned. Remember that the switch enters negative, and if we follow the track, right here we already have the capacitor with thick solders. If we go back a little further, up there, we already have the rectifier. Negative, we turn it around and we have the negative of the rectifier, and on the other side the positive of the capacitor. Here there are jumpers, which will be made in the switched power supply, and here there are jumpers that go towards the positive of the IPM. Here we have the IPM as you can see. If we go back, in the power supply we have a reactor, a PTC, a filter capacitor, low-pass filter, coils, the fuse and varistor. Here we have all the components that we were analyzing in the training. If we go a little further towards here, we have the communication, the involved diodes, and the optocouplers. We have it all in these inverter boards, and we have it all without completely disassembling the equipment. By disassembling very partially, we already have access to all the measurements we need. So, we are going to proceed to make some in the outdoor unit, and then we will move on to the indoor unit. Please leave a comment if you have any questions.